Okay, before we move into our quadratics and polynomial unit, we're going to jump to chapter 12, which is called probability and statistics, because these are some things that show up especially in science classes and in other classes that sometimes get pushed to the very end of a class and don't get covered. The beginning of this book has chapter 0, which are like prerequisite things that you should know already. So we're going to start here and do a couple little sections out of it before we jump to chapter 12. So the first section is 0-4, and it's called the counting principle. And so some words that you should know. When you're talking about probability or how many ways can something happen, the sample space is just a set of all possible outcomes. So if you're talking about flipping a coin, the sample space would be heads or tails, because that's what could happen. The outcome is what actually happens when you do it. So if you flip the coin and you get heads, then that would be the outcome. And we're talking about dependent events later, but independent events are events that do not affect each other. So if I flipped a coin and rolled a die at the same time, those are independent of each other. So some vocab you should know. And then this one says, a sandwich menu offers a choice of white, wheat, or rye bread with one spread chosen from butter, mustard, or mayo. How many different combinations of bread and spread are possible? And I enjoy the rhyming part of this question. So one way to do this would be in middle school that you'd make like a tree diagram, I think it's called, right? So like if you have a choice of white, wheat, or rye bread, for each bread you can choose from butter. I was about to abbreviate that. That wouldn't have been good. Mustard or mayo. And the same thing on this one. I'm going to put B. Mustard is MU and mayo is MA. And for rye bread, we also could have butter, mustard, or mayo. And so the question is, how many different combinations are there? And if you make a tree diagram, you can just add up these, right? There are 3, 6, 9 combinations, because you could have white with butter, white with mustard, white with mayo, wheat with butter, wheat with mustard, wheat with mayo. So there are 9 possibilities. Now, obviously, if there's like 8,000 possibilities, doing a tree diagram doesn't make sense. So that's why, hopefully, you kind of are somewhat aware of the fundamental counting principle that says if you have 2 events, event M and if event M can occur in M ways and event N can occur in N ways, then the number of ways that it can occur is just M times N. So if we have 3 types of bread and 3 types of spread, we don't have to make a tree diagram because we can just say there are 9 total ways that can happen, right? So just using that idea, it's very easy to come up with solutions to this. So it says, if you're going on vacation to the beach or the mountains, that's 2 ways. With transportation by car, plane, or train, that's 3 transportation. So how many ways can you go on vacation? That would be 6 total ways, okay? But it doesn't always work that easy that you can just multiply right away. So like passwords. It used to be that your password could just be a 4-digit number. Most ATM passwords are still that way, but now there's lots of other things with one character, an uppercase and a lowercase. It makes a lot more possibilities. But it says, suppose your password on your phone is a 4-digit number. How many possible codes could there be? So you have to think about the possibilities for each digit. So a 4-digit number, I like to make 4 little blanks. And the possibility of each number, that's the fundamental counting principle. So that's why we're going to multiply these together. So the question is, how many different digits are there? And hopefully you said 10, because we're a base 10 number system. 0 through 9 is actually 10 numbers. And since it doesn't say we can't repeat ourselves, right? Your password could be 0000, that for every digit there are 10 numbers, right? So your answer here is 10 to the 4th, or 10,000 different codes from just 4-digit numbers. Dependent events, so those would all be independent because each one is separate from the other. But a dependent event is where the outcome of one event does affect the outcome of another event. So if you want to take 6 classes next year, assuming that each class is offered each period, how many different schedules could you have? And I know that that doesn't apply here because it's a very small school and Algebra 2 isn't offered every period, but at a really big school, that would happen. So we're saying each class is offered each period, and we want to take 6 classes. So the first thing I'm going to do is I'm going to make 6 little marks here. And how many classes could I choose for first period? Well, I would choose from all 6. But now this becomes a dependent event because I already chose math for first period because it's my favorite. How many do I have left to choose from second period? Well, now I only have 5 classes. And then I chose English second, so what do I have left? Well, I only have 4 periods, right? And when I get down to the last period, I only have 1 class less left to choose from. And so that's going to count down. That would be dependent. And I'm going to multiply this together, which you can totally do on your calculator. And maybe you've seen this before. If you take a number and you multiply by every number less than it until the very end, that looks like this. So maybe you can say 6 because it's a really excited 6. That's really called 6 factorial. I just like to yell and see if I can scare you when you're watching this. It's kind of my goal. So 6 with the exclamation mark is really called 6 factorial, and it means to multiply every number from 6 down to 1. All right? Oh, I guess I should multiply that out. I think it's 120. Is that true? I guess I'll get a calculator. I was too worried about yelling. 4 times 3 times 2 times 1. Oh, 720. I was way off. 720 ways you can make that schedule. So it says Abby is registering for a website. She must select a password that contains 6 digits. How many possible passwords are there if no digit can be used more than once? So again, it's kind of like this, right? 6 digits. But how many digits could she choose for the first one? Well, there are 10 digits, but we're saying you can't repeat it. So each one's going to go down by 1, and when she gets to the last one, she only has 5 digits. Is this the same as 10 factorial? No, because we didn't go all the way to 1. So you have to do 10 times 9 times 8 times 7 times 6 times 5. And that would be just for a 6-digit password. If you can't repeat the numbers, would be 151,200 ways that can happen. Okay, so I'm also going to go ahead and talk about permutations and combinations, which I don't know if you've seen this before or not, but a permutation is when a group of objects or people are arranged in a certain order. So if order matters, it means permutation, so you have to know that. And so there's a formula for this. So if I take n objects r at a time, the way we write it is p comma, or parenthesis n comma r. Also, you can write it as n with a p in the middle and then r. That's also another way to write it. And the formula is you take n factorial, so the number of items you take, over n minus r factorial. So let me show you what I mean by this. It says 8 people enter a best pie contest. How many ways could there be blue, red, and green ribbons awarded? And so that's like first, second, and third place, right? And so we are saying there are 8 total people, so that would be our n, and we have 3 ways you can win, so that would be 8p3, or that's the same as saying p parenthesis 8 comma 3. Those are both ways of saying this. And you could say 8 factorial over 8 minus 3 factorial, or that would be 8 factorial over 5 factorial. And if I didn't have a calculator, I really like this, because if I multiply, or if I write it all out, the ones on the bottom are going to cancel out with a bunch on the top. So I just get 8 times 7 times 6, which I think is 336 ways. There is a factorial button on your calculators. I'll show you in class, but for my calculators, it's under the probability button, which is the PRB button, and I'll show you that in class, okay? Permutations with repetitions, that's where if you want to see how many ways you can rearrange the letters in something. And so that is a different formula, and that's n factorial over p factorial q factorial, which are like the number of times it repeats, okay? So n is the number of objects. P and Q are like each number of repetitions. And I'll show you what I mean by this in an example. Repetitions. Where's my time at? 10 minutes. Okay. So how many different ways could you rearrange the letters in banana? Well, that would be a permutation with repetition. So if none of these repeated, I would just take 1, 2, 3, 4, 5, 6 letters. It would be just 6 factorial. But I have to divide by each letter the number of times it repeats. So B doesn't repeat at all. If you wanted to put 1 factorial here, you could, but 1 factorial is just 1. So I only include repetitions. So there are 3 A's. So that would be 3 factorial, and there are 2 N's, so that would be 2 factorial. So be careful typing this in your calculator if you're using the factorial button. I just like to write it out and cross stuff out. Like 3 factorial would be 3 times 2 times 1, and 2 factorial would be 2 times 1. So I could cancel out this, not 2 times 2. But I could divide this 2 and then with this 4, which is a 2. So 30 times 2, I think, is just 60 ways that could happen. Not that they would all spell words, but it would be 60 ways. And then the last thing I want to talk about is combinations. So the big idea is permutations, order matters. Combinations, order does not matter. And so there's another formula for this. C parenthesis in choose R, or you could say in CR. That's another way to write it. And this one's a little more complicated because order doesn't matter. It says order. You would take n factorial over n minus r factorial also times r factorial. And so I'm going to do one, and then in class I'll show you how to use your calculator to do it, okay? But it says 5 cousins at a family reunion decide that 3 of them will go to pick up pizza. How many ways can they choose the 3 to go? Can they choose? So order doesn't matter. It doesn't matter who you pick if you're all going in the car. And so this would be 5 choose 3. So that would be 5 factorial over 5 minus 3, which is 2 factorial, times 3 factorial. So 5 times 4 times 3 times 2 times 1 over 2 times 1 times 3 times 2 times 1. So again, this cancels out. The 2 divides into 4, which means there's only 10 ways to do that since order doesn't matter. Whenever you see problems that talk about there's 1,000 ways to order a sandwich here, that's doing a combination. All right, so in class we'll practice this and we'll use our calculators too.